السلام عليكم.
وعليكم السلام ورحمة الله وبركاته.
عليكم السلام.
طيب بسم الله الرحمن الرحيم. كيف المشكلة؟ Okay. How was the midterm exam?
Easy, thank you, Doctor.
Alhamdulillah. It was good.
It was beautiful.
Very good. All right, great. So, inshallah, you did well. Inshallah, generally speaking. Yes.
Doctor,
Yes.
how was the grades?
Yes.
The grades of the exam.
It is with the university. I don't know والله. إلى الآن ما جاتنا حتى احنا. Officially يعني ما جاتنا.
No.
Okay, still with the university. I don't know why, but they are still with the university. So, of course, nobody knows his grade, right?
Yes.
I don't know, but inshallah شكلها it was, as you said, good grade inshallah. Anyway, yes, we'll continue with chapter 7. We'll finish chapter 7 today, and then by the end of today, I will put for you the homework for chapter 6 and 7. I'll open them today, and they're required. I will make them required by next Sunday. And of course, this Thursday there will be no class because for the exam. So Thursday we will meet today and Wednesday, but Thursday there is no class. I will write this to you in the WhatsApp group, okay? And then next Monday we will have a quiz on chapter 6. I will write this also to you. I don't know if it's going to be 6 and 7 or only 6. So it depends.
Doctor.
Right?
Doctor.
Yes.
You know the average of the midterm?
Not yet. All right. Right. Last thing I talked about was the ionization energy. That first, what's this?
Electrostatic force.
What's this called?
Effective nuclear charge.
Effective nuclear charge. Z effective means effective nuclear charge. What does this equal to? Yes. What's this Z?
Efficiency.
The atomic number.
Exactly. And what's sigma?
Shielding or screening.
Shielding. Sigma is shielding. All right. And of course, and we said that as you go across the periodic table, what's happening to Z effective?
Increases.
Increase.
As a result, what happened to the size?
Decrease.
Decrease.
So size decrease. And then, of course, if you are in the periodic table, if you go from up, from bottom to top, what's happening to the size?
It will increase.
No, if you go from bottom to top,
Decrease.
decrease also. So that's why we said that we have this question, which is if you have P, S, and O, they're this order in the periodic table. Which one is the smallest? As you go up, what's happened to the size?
Decrease.
Decrease.
Decrease. And as you go across, what happens to the size?
Decrease.
Decrease. Exactly. Okay, so which one is the smallest among these three?
Oxygen.
Oxygen. And next, which one is just below?
Sulfur.
What?
Sulfur.
Silver.
No, it's the other one. Yes. So this one, and then next, phosphorus is the biggest, largest. Good. We went this last time. Then we talk about ionization energy. These are the ionization energy. Again, generally, as you go across the periodic table, because of Z effective, what's happening to the ionization energy? First, let me ask you this: what's the ionization energy? Give me a reaction for the ionization energy.
The amount of energy required to release one electron in gas state.
Yes, it must be in gas state. A goes to what?
Electron plus A plus.
A plus gas plus electron. This is called the energy with this thing, delta H for this reaction is equal to what? Ionization energy. Delta H is ionization energy. Is this clear? Good. Now,
Yes.
as you go across the periodic table, what's happening to this effective? Increase.
Increase.
What is happening to ionization energy?
It will increase.
Also increase. Why? Because we have more Z effective and ionization energy will increase. And you look at the first period here. What's happening generally? As you go across, the number increase from 20 to 2080. Good. What's happening if you go down in the periodic table?
Decrease.
Number will
decrease.
decrease.
As you can see, it's decrease. The ionization energy decrease. Good. And let's go back to the across in the period in this period. What's happening to the is it always increasing as you go across, or
No.
there are exceptions?
No.
There are exceptions, right?
Yes.
What are the exceptions?
Yeah.
PE and
E
B.
and B.
PE and B, yes. Why is this exception?
Sulfur.
Because PE in the S and the P is in the P.
Yes, because we are starting a new p orbital, and it's easier to take the electron from the p orbital than from the s orbital. That is here. It's easier to take the electron, easier to remove the electron from p compared to s. Harder to remove. And that's why this becomes exception. So, because we are starting a new p orbital, this becomes less than this one. How about, is there any other exception?
Sulfur and phosphorus.
Nitrogen, oxygen.
Yes, first period, of course, yes, it is with sulfur and chlorine, I mean phosphorus. But look, nitrogen and
Oxygen.
nitrogen and oxygen. Why is this exception? Yes?
The force repel.
Because in the, this is the N, nitrogen, and this is oxygen. See, you have 3 electrons, 1, 2, 3, but here you have 4, 1, 2, 3, 4. What's happening to these 2 electrons?
Cancel each other.
What?
Repel.
Repel each other. Repel each other. As a result, what will happen? The electron will be removed easier. Is this easy? I hope. Of course, you will notice the same thing between phosphorus and sulfur. It becomes less than, when you go down, it becomes less important. Even still here, this one is less slightly, but now things are not the same. So it applies only to the first and second period. Even the third period, don't worry. I mean, it's not important. Okay, good. I hope this is clear. Next. What's this?
Ionization energies.
Ionization energy. What do we call the reaction which is a gas goes to a plus gas plus electron? What do you call this energy? Delta H equal to what?
Ionization energy.
But which ionization energy?
First one.
First, then if we have A plus gas goes to A2 plus gas plus electron. What do you call this?
Second ionization energy.
Ionization energy. Can you write the third ionization energy? What's the third ionization energy? Write reaction.
It is A plus 2.
Plus that.
Two.
It's A plus 2 go
To A plus 3 plus electron.
plus everything is gas, of course. Plus electron. What's the energy for A gas to
Third
A2
ionization
plus
energy.
gas plus 2 electrons? What's delta H for this reaction?
Which element?
What's the ionization? What's the delta H?
First
Minus
ionization.
no.
Plus 2.
Any
First
element.
plus second.
1 plus 2 ionization energy.
It's first plus second. You are adding these two together. Of course, if I write A gas goes to A3 plus gas plus 3 electrons. What's this delta H?
One plus two plus three.
Exactly. Clear? Very good. Okay. Why? What do we call the last sp orbit or sp electrons? What do you call them?
Valence.
Yes.
Valence.
Exactly. Last sp electrons are called valence electrons. Exactly. And what do you call the electrons that are not valence?
Normal electrons.
No, there is a name for it.
Non-valence.
No. Valence, these are called valence electrons. And then after that, the rest of the electrons are called what? Core electrons. Core electrons. You have to memorize this number, the names. Valence electrons are the last S and P electrons. S and P electrons, last S and P electrons. Okay, now look at this table very well. Look at lithium. We have the first ionization energy is 520. The second is 7,298. Why do you think this big jump?
Because it's core electrons.
When we lose the valence electrons, then we'll go to the core electrons. It's not easy to take the electrons from the core electrons, and that's why this big jump. When we go to BE, what's the first ionization? 899. What's the second ionization? 1757. The third ionization? 14,000. What happened?
Big jump.
Why?
Because it goes to the core electrons.
How many electrons? What's the valence of lithium?
Lithium,
Lithium.
1,
What?
E. B.
2,
Okay. How about B?
3.
How about
1.
4? How about nitrogen?
5,
How about oxygen? 6.
6,
Fluorine. 7. Neon.
0.
And 9. Sodium.
1.
1. Yes. Let's look at nitrogen. When we are going to see the big jump?
after 1 electron,
What?
after 1 electron,
No, nitrogen.
or nitrogen.
Before the last one. Before the last one.
Actually, after what? After 5. Why? The 5, all the 5 are what?
Or valence
Electrons. So as you go from this one, what happened to this, to the numbers? Increase, 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 increase. But when you go 1, 2, 3, 4, 5, when you go to 6th one, what happened?
Big jump.
Why is that?
Valence
Because
electron.
the core
Not
electrons is harder to take.
Okay, very good. This problem. Let's have for sodium and Mg. Which one will have a higher first ionization energy? First,
Mg.
Mg.
Mg is greater than sodium. Why is that?
It is have
because Mg in the second group and then in the first group.
As we go across, what happened? So this is Mg. Mg comes Mg comes after sodium, and that's why it's higher. That's the first ionization. Okay, which one have second ionization energy?
Sodium.
Sodium, because it is core electron.
Because we're going to take from core electron, which is higher than this one. Still, the second ionization will take it from valence electron, and that's why it's higher for sodium. Good. Okay, next. The second subject that we're going to talk about is called electron affinity. Electron affinity. Electron affinity is same like ionization energy, but reverse. This means you have A gas plus electrons goes to what? A minus gas. What's this called?
Affinity.
Delta H for this one, the delta H for this one is called what? Electron affinity. What's the meaning of affinity? This English word, like English. By the way, you can say I have affinity to rice. What's the meaning of affinity?
ميول.
You like. The meaning of affinity is like. All right. I can say in English. I can say I have affinity for rice. يعني I like rice. Right? Okay. My question is, why do they call it electron affinity? It like to add the electron. The energy that goes with this one is called what? Electron affinity. Of course, this is the first electron affinity. Can you tell me what's the reaction for second electron affinity?
A minus plus E.
A minus gas plus E goes to what?
A minus 2.
Exactly. This is called electron affinity. Delta H equal to the electron affinity. Okay? Okay. Always delta H is equal to the electron affinity was written in Arabic, in positive letters. Always the electron delta H, keep this in mind. Delta H equal to what? Minus electron affinity. Clear? That's why if I ask you what is the electron affinity for chlorine atom, what's the answer?
Minus the electron affinity of chlorine.
What's the electron affinity of chlorine?
Minus
349 plus 349. Why is that? Because what's delta H? The enthalpy of this reaction. Is minus 349. Is this clear? Okay.
Yes.
Now, the electron affinity for nitrogen atom equal to 7 minus 7. What's delta H for this reaction? Nitrogen gas plus electron goes to N minus gas. What's delta H?
7 positive.
plus 7. Plus 7.
Plus 7.
Delta H equal to what?
Plus 7.
No, plus delta H equal to what? Minus
Minus affinity.
This is the table for electron affinity. Of course, don't memorize any number, but always this is the electron affinity. If I tell you what's delta H for any atom, what should you do with the electron affinity?
Change the sign.
Change the sign. This is the trend. There is no trend here. It's confusing, but I wanted to notice that in the last group, from fluorine to chlorine, what happened to the electron affinity? From fluorine to chlorine.
Increase.
Increase. And then when you go from chlorine to bromine to iodine in the same group, what happened as you go across?
Decrease.
Decrease. So generally it is decreasing, but fluorine is not decreasing, it's coming the other side. Why do you think this is the reason? Why fluorine, if it goes normal, iodine, then bromine, then chlorine, fluorine should come here, right? Right?
Yes.
But fluorine is coming down here. Why? It's not here, it's down here. Why is that? Because fluorine is small, is small in size, and when you add electron, what will happen? There will be repulsion. What's the meaning of repulsion?
Go far from each other.
Yes, and that's why they don't want the new electron to come. Is this clear? I hope so. Good. Now, for the electron affinity, like electron, ionization energy, it is easier to add electron to NS group. It's easier to electron here than here. All right. So if I have lithium and Be, which is having higher electron affinity?
Be.
Oh, why? Wrong. It's easier to put electron here than here. It's harder. So which one will have higher?
It is Be.
Electron.
It is
Lithium, because it's easier, and that's why this is a higher electron affinity. All right? But so lithium is greater than Be, greater than Be. Is this clear? Okay. Which one is easier, to put the electron here or to put the new electron here?
Lithium.
This is, by the way, this is carbon and this is nitrogen. Which one is easier to put electron in, carbon or nitrogen?
Carbon.
Why?
لأنه ناقص واحد.
Electronegativity affinity is smaller, bigger.
Electron affinity
Electron T is 4.
for carbon is greater than nitrogen. Why is that? Because you are putting the electron where? Here. In the new room. But when you put electron here, what will happen?
Repel.
loss of energy.
Repelled.
Then they don't want to become in the same room. This means this electron does not want a roommate. He wants to live in the room by himself. All right? Okay, that's why, let's go back to the electron affinity. Which one is greater electron affinity? Carbon or nitrogen?
Carbon.
Carbon.
Compare lithium to Be. Which one is higher?
Lithium.
E is greater than B. And I gave you the reasons in here. Lithium is greater than Be, and same thing with carbon is easier than nitrogen. Is this clear? Let's compare these two. Compare aluminum or silicon. So aluminum or silicon.
Aluminum is the greater.
Go to your periodic table and tell me which one will have higher electron affinity, aluminum or silicon?
It is aluminum.
Tell me what's the last orbital of aluminum. It's
It is B.
it's 2p1. How about silicon? 2s2.
2B2.
2p2. Which one would be easier to put electron in aluminum or in silicon?
Aluminum.
Come on. Wrong.
Aluminum.
No, wrong.
Silicon.
Silicon, of course. Why? Because more Z effective. And you are adding the electron in this room, a new room, no problem. But this one, you'll add it here. But this one is more Z effective, and that's why silicon is higher than aluminum in electron affinity.
That confusing, doctor.
Then why lithium is easier than?
Yes, very good. Let's go back to lithium or the same group. In the same group, how about sodium and Mg? Which one would be easier?
Na.
Sodium.
Sodium has one electron, and Mg has 2 electrons. But these rooms are all empty. Okay? Okay. Which one will have higher electron affinity?
Sodium.
Sodium. Why? Because for the 2s, it's easier to add in the 2s than in the 2p. Okay, even though there is repulsion, but because this one is very close and the Z effective become more important, and that's why it's easier. So sodium is having higher electron affinity than Mg. But here, before that, here there are already electrons we're adding to the p orbital. So which is easier to add here with the new electron, or here? It's easier to add here. Why? Because of Z effective is higher. Is this clear? Okay, now let's compare silicon and phosphorus. Again, silicon and P. Silicon is having 2 electrons in 2s. This is the core electron, 2s, and then 2 electrons in 2p. How about phosphorus? Phosphorus has 2 electrons in 2s and 3 electrons in 2p.
It is silicon.
Which one is easier? Which one having higher electron affinity?
Silicon.
Silicon. Silicon is higher than phosphorus. Why is that?
Easier to add.
Because you have one room left or one place
Easier
of
here.
electron.
How about if I had here, what will happen?
It will be
There will be what?
repulsive power.
Repulsion. Repulsion. Yes. Is this clear? So, silicon is higher than aluminum, and silicon is also higher than phosphorus. Electron affinity. Clear? Good. Hope so. So now, metallic characters. We know that in the periodic table. Look at your periodic table. Where are the metals?
Left of the periodic table.
How to the one then the metal? We have metals, non-metals, where are the non-metals?
On the right.
On the right.
Okay, what's the element in between them? What they are called?
Metalloid.
Metalloid.
Metalloids. Give me example of metalloids.
Silicon.
Germanium.
Observe from the top. Boron, and then what?
Silicon.
Yes, silicon, exactly. What else?
Germanium.
Germanium.
S.
I don't have periodic table, unfortunately. I wish I had periodic table. And so you can see, okay, anyway, what's the property of metals?
Can transfer electrical energy.
The metals are shiny. When you look at any metal, you'll find that the sun can be reflected, shiny. It's lustrous, and malleable. Malleable, you can make lustrous. Malleable means you can make sheet. Malleable. You can make sheet of metals. صح? Okay. It's good conductors of electricity. Metals are good conductors of electricity and heat. Why is that?
Because it has free electrons.
Electrons are almost free. Okay. It usually have low ionization energy. Why is that?
Easy to lose electrons.
Easy to remove, exactly. Easy to remove. Like for example, sodium can easily goes to sodium plus electron. Okay, and it forms ionic compound with chlorine, right? Like for example, give me example of ionic compound with chlorine.
NaCl.
And it can make basic ionic compound with oxygen. Give me example of compounds with oxygen.
Aluminum oxide.
Aluminum oxide.
A2O.
But also
Na2O.
Good example, aluminum oxide is also ionic compound of aluminum oxide, and it also make basic compound like NaOH with oxygen. Okay, good. Now, so these are the properties of what? Metals. Okay, the non-metals are very usually colorful. For example, what's the color of sulfur?
Yellow.
Yellow, very good. And what's the
Phosphorus.
huh? What's the color of bromine? You know it? I don't think so.
Green.
No, bromine is actually very dark brown. And so on and so forth. They are usually colored. Okay? They lack shiny appearance. Are they shiny? Can you reflect the sun on them?
No.
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 Okay, not like metals. They are brittle. ايش معنى brittle?
هشة.
Yes, قابلة للكسر. قابل للكسر. Okay. Okay. They are not malleable. ايش معنى malleable?
قابلة للضرب أصلا.
مرنة.
Means you can make sheet, you can make wire out of it. Good. They are what? Poor conductors of heat and electricity. Why is that?
Because it's hard to lose the electrons.
Exactly. It's hard to lose the electron. In fact, it wants the electron, but it doesn't give the electron out. Exactly. So hard to lose electron. Okay. They form acidic compound with oxygen. Give me example.
HCl.
No, with oxygen. HCl.
H2.
What's this acid?
Chloric acid.
Chloric.
Chloric acid. All right. That's why. What's this acid?
Sulfuric.
Sulfuric acid with oxygen. Okay. Have high electron affinity. Usually they have high electron affinity. Why is that?
Z efficiency.
Yeah, but why high? Yes, Z effective is high. Very good. What else? Because they like to add electrons. They like to take electrons. They like to make what type of anion? I mean anion, not cation. What's the meaning of anion?
Take electrons.
Negative ion.
Ion. While metal, this is for non-metal. How about metals? What do they make? Metals make what?
Cation.
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 Which is what? Positive ion. Positive ion. Very good. Now, the elements in between, they are called what? Metalloids. What's the properties of the metalloids?
It is weak conductor of electricity.
Metal and non-metal.
Read this word. Intermediate.
In between them.
In between, intermediate. It is in between them, all right? Between the metals and the non-metals. Metals and non-metals. Good. Okay. Now, good. Now, all right. Now I want to define two things. First, isoelectronic. What's the meaning of iso?
It is the same electronic
No.
Charge.
I'm talking about the word iso. Iso means what?
Same.
Same. Iso means same. And electron, everybody knows what's electron. Iso, electron, this means what? The same?
Electronic.
The same number
of valence electrons.
what? No, of electrons. Of electrons. Same number of electrons. Okay, good. Example. What's the structure of Ne? Neon.
1s2, 2s2, 2p6.
What else? That's it? Good.
Yes, it's 10.
What's the electronic structure of sodium?
1s2, 2s2,
Yes.
2p6,
Yes.
3s1.
Fantastic. Thank you very much. I'm not going to write that, but I want you to tell me what's the electronic structure of Na plus.
It is 1s2, 2s2, p6.
One is
Same as neon.
2 is 2, 2p6, exactly like neon. What do we call these two atoms together?
Isoelectronic.
Isoelectronic. Now compared to F minus. Structure of F, what is it? F.
1s2,
1 is 2, 2 is 2,
2s, 2p5.
2p5. How about F minus?
2p6.
2p6. Is there a relation between these three atoms?
Yes.
They have what?
The same amount of electrons.
Isoelectronic.
They are isoelectronic. Is this clear? Now, how many protons do we have for sodium? Look at your periodic table.
11.
How about neon?
10.
How about fluorine?
9.
9. Now, if we have the same number of electrons exactly, but we have different number of protons, okay, which one is the smallest size ion or atom?
Neon.
Which one is the smallest in size?
Fluor.
Smallest in size. Wrong.
Positive.
Positive what? لحظة يا شباب. كيف احنا نتحكم في السايز؟ ايش اللي يتحكم في السايز حق الاتم؟ Z and the number of electrons, right?
Yes.
Okay, they are all having the same number of electrons, exactly the same structure. Everything is the same. Which one will have the smallest size?
It will be the least
Same size.
Smaller size come from what? Stronger what?
Z.
Stronger attraction. Which one will attract the electron stronger? Sodium or neon or fluorine?
Sodium.
Why?
Because it loses electron.
Yeah, because
It has 11.
11 protons. They have the same structure from outside, but this one have 11 protons, this one is 10, this one is 9. The 11 will attract the same number of electrons, which is 10 electrons in all of them, stronger than this one, stronger than this one. So in this case, F minus, I will organize them, Ne and then N. What sign should I put in size?
Bigger.
Bigger and bigger. Is this clear? I hope it's clear. Okay, I can write the structure of the neon, which is 1s2, 2s2, 2p6. And then instead of writing this whole structure, I will write the structure as neon like this. So I want you to tell me what's the structure of Na plus.
The same as neon.
Ne.
So I can write it like this. When I put it in this big parenthesis, what does it mean? It has the same structure. Okay. How about if I want to write Na? What's Na? The structure of Na?
-2.
Ne 3s1.
3s1. I want you to know how to write these things. Always we depend on the noble gas that comes before it. Noble gas that comes before it. And that's why if I want you to write the structure of chlorine, go to your periodic table and tell me how are you going to write the structure.
One is 2, 2 is 2, 2b6, 3 is 2,
Yes.
3b 5.
5. I wanted to make it the short form.
Ne 3s1.
And
Ne2.
first, because this is the noble gas that comes before chlorine. Okay, and then Na 3s2, and then 3p5. This is the electronic structure of chlorine. Okay, but if I want you to write
Doctor,
the structure of Cl minus, what is it?
3b6.
Ne 3s2, B3, B6.
No. Go to the next periodic.
Will be
Argon.
Argon, because it's argon, exactly the noble gas argon. Is this clear?
I didn't understand, Doctor.
Always go to the noble gas that comes before it. So chlorine, neon comes before it, and then you write neon and then 3s2, 3p5, because the structure of chlorine, this is neon. You have to memorize neon. Chlorine is 1s2, 2s2, 2p6, 3s2, 3p5. Now, all of these are actually the structure of neon. So instead of writing the whole structure, I will write the structure of chlorine as neon 3s2, 3p5. Is this clear? Now, if I go to Cl minus, then it becomes 1s2, 2s2, 2p6, 3s2, 3p6, which is the structure of which noble gas?
Argon.
Argon, exactly, and that's why the Cl minus structure is simply argon.
Clear now. Thank you.
That's good. Next, which one is bigger in size? Cl minus or argon?
The same.
No, they will never be.
Cl minus.
Which is bigger in size?
Cl minus.
Yes, why is that?
Have a higher electro affinity.
No, nothing to do with the electron affinity.
Protons.
How many protons do you have for Cl minus?
17.
70.
How many we have for argon?
80.
18. But the electrons outside, they are exactly the same. That's why we say Cl minus is like argon. Which one will have bigger size, Cl minus or Ar 0?
Cl minus.
Why is that?
Less number of protons.
The number of protons is less, and that's why Cl minus is bigger than argon. I hope this is clear.
So, Doctor, the atom with less number of the protons is bigger?
Yes, let's do this one. We will understand that. Okay. Right, what's the structure of N3 minus? Go to your periodic table.
It will be Ne.
Ne.
Neon.
Is it neon? Yeah, Ne. Yes, yes. Okay, exactly. Fantastic. Is this clear? Very good. How about Ba2 plus?
Xe.
Xenon. Exactly. And then is there an electron after that?
6s2.
No, it's 2 plus already.
Wow.
So this is the
Yes.
structure, that's it. Okay. How about Be2 plus? What's the structure?
Helium.
Helium.
Exactly. Because you lose the extra electrons. At the end, you'll have only 2 electrons, like helium. How many electrons do we have for neon? What?
10.
10. Very good. How about for nitrogen? How many electrons we have for nitrogen?
5.
Electrons, all electrons, not valence.
70.
7.
7.
7. 7. So when we add 3 minus to it, then what will be the total?
10.
10.
10. What will be the structure if we have 10?
Neon.
Neon.
Is this clear? Very good.
Yes, doctor.
When we have transition metal, like this transition metal, what's the structure of transition metal, Fe? Do it the long way. It's 1:2, 2:2, 2p, 6, 3:2, 3p, 6, 4s2, 3d6. This is the electronic structure which I told you to do in chapter 6. Do you remember it?
Yes.
Very good. I hope so. Good. Next, what's the structure of argon? 1:2, 2:2, 2p6, 3:2, 3p6. Can you write the structure of Fe using argon?
We put 4s2 in the 3d6.
2, 3d6. Good. Is this clear? Okay.
Yes, doc.
the 4s comes before the 3d, and we put the electron in 4s before the 3d. Is this clear? But when you lose electron, even one, but I will do it for 2 plus. When you lose electron, you lose it from the S, not the D. And that's why Fe2 plus, what's the structure of Fe2 plus? What is that? Fe2 plus means we lost how many electrons?
Force 1.
How many electrons? Fe goes to Fe2 plus, how many electrons lost?
2.
2.
Electrons. Where are we going to lose electrons from?
Force.
Yes.
And that's why the structure will be like this. Even if you have 1 electron, if I have, for example, Fe plus, what will be the structure?
Argon for
For-
Force 1. 3d6.
D7. Tell me why. Tell me why.
Because it does not, we can put only 1 electron in S.
No, because there were 2 electrons in S. When you have any charge, the next electron will go. But we cannot make the 2 goes. So 1 will go out to make it plus, and the other one will go to the D level. And it will be 3d7. Is this clear?
Doctor,
Yes.
this is for Fe or any transition metal?
Any transition metal. Clear? Good.
Yeah.
Now, let's do. This is the blue thing here is the size of the atom, and this is the gray here is the size of the ion or the cation. Okay. Which one is bigger, the atom or the cation?
atom.
Why? Why the cation is smaller than the atom? Again, what's the structure of lithium? It's 1:2, 2:2, sorry, 2:1. Well, for lithium plus, what's the structure of lithium plus?
1:2.
1:2. Which one will be bigger in size? Lithium or lithium plus?
Lithium.
Because you lose this orbital, you lose it completely, and that's why it's smaller. Okay, how about this is the size of chlorine atom, and this is the size of -1 or the anion. Which one is bigger, Cl or Cl minus?
Cl minus.
Cl minus.
Why Cl minus bigger than Cl?
Because it's
He
gained.
has full orbitals.
Because you added electrons, and the electrons repel each other, and that's why it becomes bigger. There was only 7 electrons here. 1, 2, 3, 4, 5. And here in the second Cl minus, you have 1, 2, 3, 4, 5, 6. You are adding electrons. The electrons repel each other, and this become larger in size. Is this clear? Don't memorize any number here, but you have to know that always which one is bigger, Na or Na plus?
Na.
Which is bigger, Na plus or Na2 plus? Always, whenever you lose, the size becomes smaller, smaller, smaller. Okay, now if I have, which is bigger, O or O minus?
O minus.
O minus.
Which is bigger, O minus or O2 minus?
2 minus.
2 minus.
Exactly. Always, whenever you add electron, the size becomes bigger. Whenever you take electron, the size becomes smaller. Very good. Now, let's look at these atoms, and let's look at K plus, argon, then Cl minus, and then S2 minus, and then P3 minus. Let's start with argon. What's the structure of argon? 1 is 2, 2 is 2,
2 is 2.
2p6,
2b6.
3
3
is
is 2.
3p.
3b6.
Let's the other way to write it. Like this. Good. What's the structure of K plus?
1 is 2. 2 is 2.
It will be argon.
Argon.
2b6.
Exactly.
3.
Argon. Very good. What's the structure of Cl minus?
Argon.
Simply argon. What's the structure of S2 minus?
Also
Also argon. And how about P3 minus?
it will be
Argon.
So argon. They have the same electronic structure. What do we call these elements together?
Isoelectronic.
Isoelectronic. Now tell me, how many protons do you have for K, potassium?
19.
19.
How about argon?
18.
18.
How about chlorine?
17.
How about sulfur?
16.
16.
How about phosphorus?
15.
Which one of these elements is the largest in size?
Potassium.
Phosphorus.
Phosphorus, 3 minus, exactly. What's next?
Doctor, how do you know it? First.
Because they have the same electrons, but they have less protons to attract. And this become bigger. Okay, what is next?
Sulfur.
What's next?
Chlorine.
What's next?
Argon.
What's next?
Potassium.
Potassium.
Is this clear? Okay. Now I want you to compare argon with krypton. Which one is bigger?
Krypton.
Why?
Because it's down the argon, under the argon, and it has one more.
How about neon?
Less than argon.
This thing. Exactly. That's it. And with this is chapter 7. What do I mean by that? This, keep this in mind. 7.7 is what?
Deleted.
Deleted. You can see this in your syllabus as well. 7.7 is deleted. Don't study 7.7. Don't come to the final and study 7.7. This part of the chapter is deleted, and we are actually finished now with chapter 7. Any question? Okay. Before you give me any question, let me use this and this card, and let's go to attendance as usual and open the attendance. Now, if you have questions, go ahead. The attendance is open now. go ahead and register your attendance, and then if you have question, go ahead.
يا دكتور
Yes.
ممكن تأجل الكويز ليوم الأربعاء؟
ما شاء الله لسه ما تكلمنا عنه. هو مو الأربعاء، هذا الاثنين يعني. اوكي.
أيوة، لأن فيها ميد ترم يوم الأحد، ميد ترم ماث 1 أو 2.
ميد ترم 1 أو 2 يوم الأحد؟
أيوه.
إذا خلاص، إذا الكويز إن شاء الله حيكون كويز في chapter 6 and 7. It will be on Wednesday. خلاص لا حول ولا قوة. Alright.
يعطيك العافية يا دكتور.
دكتور أسئلة chapter 7 كيف بتكون بالضبط وما فيها حسابات يعني ما فيها calculation؟
كل شيء موجود دون فرق، في طرق يعني مختلفة.
تمام الله عليك.
اوكي.
دكتور.
نعم.
أنا آخر شيء لما قارنا بين النيون والأرجون والكريبتون.
نعم.
ليش ما قارنا النيون مع بقية الأيونات؟ هل يحتاج ولا لا؟
شوف البريدكتيبل حقي هو فوق مختلف عنهم في بريد مختلفة.
اي نعم.
وما تقارن كنا نقارن اللي نفس البيريد اللي هم جنب بعض، اللي نفس الالكترونيك ستراكشر. اما النيون ما الالكترونيك ستراكشر حقه مختلف تماما.
ونفس الكلام كريبتون مع الايونات.
طبعا الى انه الحين هنا احنا قلنا ان الكي بلس
ارجون
والارجون والسي ماينس واس 2 ماينس والبي 3 ماينس. ايش ميزتهم؟ all of them have one structure. ايش الستراكشر؟
اللي هو الارجون.
ايش الستراكشر؟ شو الستراكشر حق الارجون؟ 1s2 2s2 2p6 3s2 3p6. خلينا ناخذ النيون يعني. ايش الستراكشر حق النيون؟ 1s2 2s2 2p6 that's it. هل هذول في اي علاقه من ناحيه الكترونيك؟
لا طبعا.
هذا وين؟ وهذا يعني كانك تقول هذا النيون فيه الشله الاولى والشله الثانيه، في حين الارجون فيه الشله الاولى اللي 1s بعدين 2s وبعدين 2p. مين اللي حيكون اكبر، الارجون ولا النيون؟
الارجون.
الارجون حيكون اكبر. هذول كلهم لهم نفس الشكل هذا، كل هذول لأن نفس الإلكترونات فعندهم نفس الإلكترون. إيش الفرق بينهم؟ إن عدد الإلكترونات هذا 18 هذا 19 هذا 17 هذا 16 هذا 15.
الجذب يختلف.
مين يجذب أكثر، ال 18 ولا 19؟ إذا كانت النيوكليس هنا 18 أو 19 مين حيجذب أكثر الإلكترونات؟
19.
إذا مين اللي أكبر، الكي بلس ولا الأرجون؟
الأرجون.
And then the same thing with the rest. فأنا I can compare these, بس I can't compare this مع النيون. I can compare النيون مع الأرجون. I know that definitely الأرجون is bigger than neon. How about الكريبتون اللي تحت الأرجون؟ روح شوف البريدكتيبل حقك. عندك النيون تحت الأرجون تحت الكريبتون. مين أكبر، الكريبتون ولا الأرجون؟
كريبتون.
لأن هنا حتسوي حلقة جديدة فوق هذه 3 حلقات حتسوي في حلقات جديدة. واضح؟
واضح جدا دكتور، يعطيك العافية.
يا
دكتور
يس.
هل في إمكانية يصير الكويز يوم الاثنين عشان نجينا نذاكر في الويكند ونستغله؟
طيب ذاكر في الويكند وبخليه يوم 4 ما في مشكلة.
يوم 4 أقصد يوم الاثنين اللي هو بعد هذا
لا
بعد
لا
مارس.
لا مرة تأخرنا جدا. لا صعب جدا. يمكن يوم الأربعاء اللي بعده طبعا ما أعتقد الحين، بس الأربعاء اللي بعده حاطيكم كيس في شابتر 8. اوكي سوري، لا والله تاخرنا واجد احنا اوريدي متاخرين في الكويزز بشكل